Hello everyone, how are you? This is a video to give you some notes for taking your Chapter 9 test in statistics. So problem number 1 says that maybe commercial trucks violate laws at a higher rate or at a higher proportion. So it says population 1 is passenger cars. So if the trucks violate the laws at a higher proportion, then that means the passenger cars would be a lower proportion than the trucks. So population 1 should be a lower proportion than population 2. So we're testing the hypothesis to see if population 1 is lower than population proportion 2. All right, then we'll identify the test statistic. So to do that, we're going to click on Question Help, StatCrunch. And we're going to choose stats, or stat, and then proportion stats. We're doing 2 samples this time, and we have a summary of those samples. So what we'll type in is in sample 1, which is the passenger cars, there are 240 rear license that only had rear license plates. And that's out of 2,091. And then among the trucks, there's 50 that only had rear license plates out of 369. So remember, passenger cars is sample 1 according to the problem. So that goes first. And we're testing the hypothesis to see if the passenger cars are lower than the trucks. So we're going to choose lower than right there. And then that's all we need to do. So we're going to click compute. And these are the results. So the test statistic is this number right there, the Z statistic. So I'm going to copy that, round it off to 2 decimal places, so the 3 becomes a 4. Then the p-value is right here. So the 3rd decimal place is 7, that rounds up to an 8. State the conclusion. Well, the significance level is 0.01, and the p-value is bigger than that. So if the p-value is bigger than the significance level, then you will fail to reject the null. And that means there's not enough evidence. So we'll fail to reject the null because there's not enough evidence, because the p-value is bigger than the significance level. And then, now notice that's a one-sided hypothesis. And the significance level is 1%. So then it says, identify the confidence interval limits that would represent that same thing. So if you have one-sided confidence level that's 1%, then that means the two-sided would be 2% with 98% between it. So we're going to change these options and we'll choose confidence interval. And since it's a 1% significance level and it's a one-sided test, that means there's a 2% on both sides, meaning that there's 98% between both sides. So we'll click compute, and then the lower limit is right here. Round off to 4 decimal places. The upper limit is right here. 0.0237, that'll round up to an 8. And then, because the confidence interval limits contain 0, that means there is not a significant difference between the two proportions. So that means there is not sufficient evidence to support the claim that commercial truck owners violate laws at a higher rate than owners of passenger cars. All right, perfect. Now, in a study of headaches, it says that 157 patients were treated with oxygen. Okay, so let's do edit. So it says the first sample is the ones that are treated with oxygen. So the numbers for oxygen goes first. So among the 157 patients treated with oxygen, 107 were free of headaches. So 107 successes out of 157 in the oxygen group. In the placebo group, 30 were free of headaches. So there were 30 successes out of 149 observations. And we want to perform a hypothesis test. And we want to have the hypothesis that the claim is that the oxygen treatment is effective, meaning that the first sample would have a higher proportion that were free from headaches. So P1 should be greater than P2. So it would be the first one. Remember, the null is always something involving an equal sign. So if you want to test the claim that oxygen is more effective than the normal, then P1 would be greater than P2. So we're going to choose a greater than sign in this one. So change that to a greater than sign. So we're going to test the oxygen in the first sample, the placebo in the second sample, and we'll try to test the hypothesis that the oxygen works better than the placebo. So then I'll click compute, and the result I get is the test statistic is that number. It's a fairly big test statistic. And the p-value is less than 0.0001, so rounded off, that would be 0.000. The conclusion, the p-value is less than the significance level of 0.05, so that means we will reject the null. So that means that there is sufficient evidence to support the claim that the cure rate with oxygen treatment is higher than the cure rate for the placebo. So then we're going to construct a 90% confidence interval. Now remember, this is a one-sided test, so if you have a 5% significance level on a one-sided test, that means the other side is also 5%. Together that's 10%, and that means there's 90% between those two sides. So we're going to also test this with a 90% confidence interval. So we change the options and we choose confidence level 90%, and then we click compute. And then we get the lower limit is that, rounded to 3 would be 0.399. And then the upper limit is that, rounded off to 3 would be 0.562. The conclusion based on the confidence interval is because that confidence interval limits do not include 0. So the two cure rates are not equal. It appears that they're not equal. We don't know for sure, but it appears that they're not equal. Because the confidence interval limits include only positive values, that means it appears that the cure rate is higher for the oxygen treatment than for the placebo. So based on the results, is it effective? So it does appear that it suggests that it's effective. So the results suggest that the oxygen treatment is effective. Okay, now look at this neat formula. This is a neat formula if you want to calculate the sample size. So now let's look back at the question. So it says that assume you want 95% confidence that your error is no more than 0.06. Well, the confidence level representing 95% confidence, you can look that up in a table. It's 1.96. So I'll show you how to do that real quick. Because on your test you might have a different level of confidence. For example, if it's 90% confidence, then your value would be 1.645. So let's go to Stats, Calculators, Normal. Now you click Between. Now we want a confidence that's 95%. So that means that the confidence interval should equal 0.95 on the right side of the equal sign. Then we get the value of z that we need is 1.96. So it's pretty easy to memorize that because most confidence intervals are 95%, and then they'll always have a value of z of 1.96. So that's helpful to remember that number. All right, now we're going to have to remember that number, so let's see. So remember, the z is equal to 1.96 and your error is no more than 0.06. So let's look at that formula real quick. So what you do to calculate the sample size is you take your z value, which is 1.96 squared, divided by parentheses 2 times the margin of error squared, which is the margin of error is 0.06, then we square that. So 1.96 squared divided by 2 times 0.06 squared, then we get that. You always round it up. So 533.5 rounds up. Even if it was 533.1, you always round sample sizes up. So it'd be 534. So 534 and 534. Now there is another way of doing this. You can go to Stats. You can go to Stats, Proportion Stats, to sample width, right there. And then you can type in confidence level 95%, first proportion 0.5, second proportion 0.5, and the width is double the error because there's a margin of error on the right side and there's a margin of error on the left because margin of error is always something plus or minus the margin of error. So the total width is twice the margin of error. So twice 0.06 would be 0.12. So you could type 0.12 into this, and then you click Compute, and you'll get 534 people in each group. So there's two. It's a sample of 2 groups, so there's 534 in each group. Okay, so in problem number 4, it says, test the claim that the 2 samples are from populations with the same mean. So they either have the same mean or they don't have the same mean, so the correct hypotheses would be they equal each other, or the means don't equal each other. Then we're going to calculate the test statistics. So we're using, when you're doing tests from means, using the standard deviation of a sample or 2 samples, you're using the t distribution. So I'm going to go to StatCrunch and choose Stats, T-Stats, 2 samples with summary. Then I'll enter this information. So sample 1 has a mean of 2.36. Sample standard deviation is 0.95. Sample size is 33. Sample 2 has a mean of 2.63. Sample standard deviation is 0.69 and sample size is 38. And then we'll do a hypothesis test for that they're equal to 0. They're equal to each other, which means the difference is equal to 0, or they're not equal to each other, which means that the difference does not equal 0. And let's just check one thing. it says do not assume the population standard deviations are equal. So when it says do not assume that they're equal standard deviations, then that means you do not check that box. So we're not going to check the box that says pool variances. So pooling variances is only done when you assume that the population standard deviations are equal, and we're not assuming that. So do not check that box if it says that. So compute. So there we go. The test statistic is equal to this number. So round off to 2 decimal places. The p-value is that number. Round to 3 decimal places. And the significance level is 0.10. So since the p-value is bigger than 0.10, we're going to not reject the null. So we'll say fail to reject the null. And you fail to reject it because there's not enough evidence. There's not sufficient evidence. Then it says create a confidence interval. Well, notice that this hypothesis is a two-sided hypothesis. And when it's a two-sided hypothesis, then the confidence interval is based on the same significance level. So there should be 10% on the outside and 90% on the inside. So go to these options and change them. Just change them to be a confidence interval and change the level to be the same as that, so 90%, which represents a 10% significance level of a two-sided test. So then compute, and we'll get a lower limit of negative 0.60, which rounds off to 0.604, and an upper limit of that 0.064, and then notice that that confidence interval does not, it does include 0, which means that you cannot conclude that they are different because the difference might be 0. So there's no evidence that the two means are different. Just like this says, there is not evidence to reject the claim that they're the same, meaning that there's not evidence to support the claim that they're different. Okay, that's it. Then problem 5. So this says test the claim that the mean IQ scores for subjects with medium levels is higher. So assume population 1 is the ones that have medium lead levels. So we're going to click on copy to clipboard. So I'll do now. On your computer, you'll have to either do Command C if you're on a Mac, or Control C if you're on a Windows computer. So Command C, and then click Done. Then go over here to StatCrunch and close that. And then what you do is you click on the name of variable 1 and then do Command V or Control V to paste it. Whoops, actually I forgot. Hold on. You go down below there, actually, Command V. So paste that underneath the label variable 1. You don't want to paste it on top of variable 1 because there's no header that's on those numbers. There usually is a header, but this time there wasn't. So then what you'll do is you're going to find the values of statistics of those levels. So you're going to do stats, calculators, summary stats, columns. So stat, summary stats, columns. Click on variable 1. Then you'll click compute. So there's information about variable 1. Now, here's the information about variable 2. So the computer gives you the necessary information about variable 2, so you don't need to calculate that yourself. So I'm going to close this. Now, it says test the claim that the mean IQ scores for subjects with medium levels, which is population 1, is higher than population 2. So mean 1 would be higher than mean 2. So mean population 1, medium lead levels, is higher than population 2. So it would be A. And then the test statistic. So we need to know this number again. So go back over here and choose stats, t-stats, 2 samples with summary. So open this up and then have this up here. And then in sample number 1, the medium blood level of sample 1, the sample mean of sample 1 is that number. The sample standard deviation is that number. The sample size is 11. And then sample 2, we'll need to go back and look at this. Sample 2, the sample mean is this number. The sample mean is 87.831, and the standard deviation of sample 2 is 10.000. The sample size is 11. So it's 2 sample T summary, and let's check something real quick. It says do not assume the population standard deviations are equal. So that means we do not check that box. And then we're testing to see if the mean 1 is greater than mean 2. So we're going to choose a greater than sign right there. Then we're going to click compute. So there's the result. So the test statistic is that number. Rounded off to 2 decimal places, it'd be 0.61. And then the p-value is this number. The 3 decimal places, it'd be 0.256. And then state the conclusion. So the significance level is 0.10. And the p-value is bigger than the significance level, so we would fail to reject the null. So there's not sufficient evidence to support the claim that the subjects with medium lead levels have higher IQ scores. Okay, now let's do a confidence interval. So notice that this hypothesis, that is a one-sided hypothesis. It's a one-sided hypothesis with a 10% significance level. That would be equivalent to a two-sided hypothesis with a 20% significance level. So we're going to go here and do the options. Have a 20% significance level, which means it's an 80% confidence interval. And we'll click compute. So the confidence interval is right here. Rounded to 2 would be 0.11. And then right here, rounded to 2 would be 0.36. And does the confidence interval support the conclusion? Well, the conclusion was that there is not evidence that they have higher IQ scores. So this conclusion would be yes, because the confidence interval contains 0. So if the confidence interval contains 0, that means there's really no difference between the scores, no significant difference between them. And so that is the same conclusion, that there's not really higher IQ scores. All right, next problem. Okay, so we are looking at a geyser, and the hypothesis says, does it appear that the mean time interval has changed? So does it appear that it's changed? Well, it's either equal to the same thing or it's not equal to. So if it's changed, that means it's not equal to. So if it asks you, does it appear the mean has changed, you'll choose the hypothesis that says the mean has changed, which is the mean does not equal the other mean. Then open this thing and do copy to clipboard. Do Command C or Control C to copy the data. Now this time there are labels at the top of the data, so you're going to click on this label variable 1, and then you do Control V or Command V to paste it in. And then your data go there, and then you're going to do a 2 sample t-test. So t-stats, 2 sample with data, and your first variable says mu1 is the recent times. So your first sample is the recent and your second sample is in the past. And then you're testing the hypothesis to see if it's not equal. So that's good. So now you just click compute. So there we go. And the test statistic is this number, rounded to 2 decimal places, so 0.99. And the p-value is this number, rounded to 3 decimal places, so the 0.057. And then make a conclusion at the 10% level. So, since the p-value is below the level of significance of 0.10, the p-value is less than the significance level. That means we will reject the null because the p-value is less than or equal to the significance level. When you reject the null, that means there is sufficient evidence that the alternative hypothesis could be true. So there is sufficient evidence that the mean time interval has changed because that's the alternative hypothesis. Now it says, is the conclusion affected by whether the significance level is 0.10 or 0.01? Well, it is actually affected because if we had had a significance level of 0.01, then the p-value would have been bigger than the significance level, and then we would not have rejected it. So the answer is yes. The conclusion is affected by the significance level because the null would be rejected when the significance level is 0.10, but it would not be rejected when the significance level is 0.01. That's because the p-value is less than 0.10, but the p-value is bigger than 0.01. So rejecting or failing to reject the null hypothesis can be affected by the significance level. Okay, now problem 7. So first of all, let me clear out my old data. So select the old data like this and then push delete. Now the delete key is the key under the insert key to the right of your regular part of your keyboard. I'm not sure if the backspace key would work. Let me just try it. So if I select that and I push backspace, whoops, the backspace key will work too. So you can push whichever one you want to delete your old data. Now I'm going to click on this data and select copy to clipboard, and then I'll do Command C or Control C to copy it. Then I'll click on the variable name and I'll do Command V or Control V to paste it. And then the data and the variable names, they both go there. And now let's see what it's asking about. It says the ages are matched according to the year that the awards were presented. And test the claim that the differences have a mean less than 0. So that would be the alternative hypothesis. The differences are less than 0. The null hypothesis would have to have an equal sign, so it would be equal to 0. So now what this means is, since the best actresses is first, that means that the difference in them is equal to the actress age minus the actor age. So if the difference between the actress minus the actor is less than 0, that means the actress would be younger than the actor. So we're actually testing the hypothesis that the best actresses are generally younger than the best actors. Well, is that true or not? Well, it depends. We'll find out. We'll find out if that conclusion is supported or not supported. So let's go back over here, and we're doing a paired test because we're comparing the ages each year. So this is coming from the same year, meaning that that's a pair of data. So click on Stats, T-Stats, Paired Data, and then sample 1 is the actresses, sample 2 is the actor. We're testing to see if the difference is less than 0, meaning the actresses would be younger. So then I'll click compute, and then I'll look at my results. So the test statistic is right here, and round it off to 2 decimals, that would be 0.29. And then the p-value is that. Round it to 3, it'd be 0.024. What's the conclusion? Well, what's the significance level? That's what matters. So the significance level is 0.05. Well, compared to 0.05, the p-value is less than the 0.05 significance level. And since the p-value is less than the significance level, less than or equal to the significance level, that means we will reject the null. That means there is sufficient evidence to support the claim that actresses are generally younger when they won the award than actors. So construct a confidence interval. So since this is a one-sided test, that means that the significance level of 0.05 is only one side. So the other side would be 0.05 as well, and both sides would be 0.10. That would leave you with 90% in the middle. So if I change these options, a confidence interval would be 90% in order to represent a one-sided hypothesis test with a value of 5%. So then I'll click compute. So there we go. And so construct a confidence interval that could be used for the hypothesis test in part A. So the confidence interval, 90% confidence interval, would be from a lower limit of -17 and round it off to 1 decimal place. And the upper limit would be that number. So -1.95 actually would round off to -2.0. And notice that the ages, if they're younger, the actresses tend to be between 17 years younger and 2 years younger. So that does support the hypothesis. So since the confidence interval contains only negative numbers, meaning the actresses tend to be younger, that means that we will reject the null, because remember the null hypothesis was that it was equal. The difference in ages was 0, meaning there was no difference between the ages. So since the confidence interval contains only negative numbers, we'll reject the null. All right, question 8. So let's delete the old data again. And let's copy the new data. Copy to clipboard. Command C or Control C. Click Done. Then click on the variable name and Command V or Control V. There you go. So it says test for a difference between the two arms. So if there's a difference between the two arms, that means the difference is not equal to 0. If there's no difference, that means the difference is equal to 0. So the hypothesis that's correct for this problem is equal to 0 or not equal to 0, meaning there's no difference or there is a difference. And so we're going to do stats, t-stats, paired, and it says that the right arm goes first, right arm minus left arm. So sample 1 would be the right arm, sample 2 is the left arm, and we're doing a hypothesis that it's either equal to 0 or not equal to 0. And compute. So the test statistic is this number right here. So -2.24. And the p-value is that number right there. So 0.089. And then then the p-value is, okay, so the significance level is 0.01, but the p-value is bigger than that. So since the p-value is greater than the significance level, that means we fail to reject the null. That means there is not sufficient evidence to support the claim of a difference. So when there's not sufficient evidence to support the alternative hypothesis that they are different from each other between the two arms. All right, then problem number 9. So we're going to, once again, copy to clipboard. So Command C or Control C, and then click on the variable name and do Command V or Control V, and then we have that data. It says construct a 95% confidence interval for the mean of the before minus after differences. And this is measuring the pain before hypnosis and after hypnosis. So we're going to do stats, t-stats paired. Sample 1 is before, sample 2 is after hypnosis. And we're going to do a confidence interval, and they want it to be a 95% confidence interval, so that's good right there. So click compute, and then you get that. So the lower limit is that. So rounds off to 0.66. The upper limit is that, which rounds off to 3.54. Does hypnotism appear to be effective in reducing pain? Well, before minus after turned out to be positive, and so the pain before you had hypnosis tends to be more than the pain after hypnosis. So that means, yes, the pain before was more than it was after, so the hypnotism appeared to be effective in reducing pain. So yes, it does appear to be effective in reducing pain because the interval does not include 0, and it is all entirely greater than 0. And then that's all. And those are your notes for helping you on the Chapter 9 test.